Hello everyone, today we're going to be proving that if A, B and C are sets, and A intersect C is a subset of B, and X is in C, X is an element of C, then X is not an element of A minus B. Okay, so let's go straight into this. So we're going to do this by contradiction. Okay, contradiction. So we're going to say, assume, okay, this is our contradiction. I'm going to say assume, and we'll say to the contrary, just so it's obvious that we are, doing a contradiction proof. So assume to the contrary, and we want to assume that X is an element of A minus B. So say X is an element of A minus B. So there's the start, very nice. And we want to show that if A, B and C are sets, and A intersect C is a subset of B, and X is an element of C, then X is not an element of A minus B. So we have X is in A minus B. So what does this mean? Well, this means that X is in A, and X is not in B. Okay, and now I'm going to say recall that, so we have A intersect C, so let's write this recall A intersect C means, what does this mean? It means, well, it means that if X is, so it means if X is in A, no, sorry, it means that X is in A and X is in B. Sorry, C. X is in A and X in C. Okay, it's in both of them. So if A intersect C is a subset of B, it means if X is in B, then, well, it's just what we've just written. So if X is in B, then X is in A, and X is in C. Okay, very nice. But now, what we're saying is that X is in A minus B, yeah. So X is in A and X isn't in B. So then X isn't in B, but we said if X is in B, then X is in A and X in C. So we can now negate this statement. So what we do here is we say that to negate this, what we do is we say, well, let's just write if X isn't in B, which is not, X isn't in A, because we're negating that first part. And now this and gets changed to an or. X isn't in A, or X is not in C. Okay, very nice. Now let's look back at our proof. Let's look back at our statement, sorry. So we have here that X is in C. Okay, this is important. They didn't just put it here for no reason, did they? So we have that X in C. So we're going to say recall X is in C, but then X in C and X is not in C. So let's write this, X in C and X isn't in C. Well, don't know about you, but this seems like a contradiction to me. So we have our contradiction. So that's very nice. Now we can just finish this off by saying, hence, if A intersect C is a subset of B. Let's fix that. That is not very nice. A intersect C is a subset of B, and X is in C. This implies that X is not an element of A minus B. So let's go over what we've done here. We said that, so we assumed the contradiction that X was in A minus B, which means X is in A and X is not in B. But then we said that A intersect C means X is in A and X is in C. So if it's a subset of B, then if X is in B, then X is in A and X is not in C. So if X isn't in B, X isn't in A or C. But then we earlier said that X is in C, so there's a contradiction, and that's our proof. Thank you for watching today. If you enjoyed this video, leave a comment down below and leave a like, please.